This video is entitled Entity Relationship Diagramming the Subject Area Model. I'm Dr. Renaud from Shawnee State University, and this video goes along with our Systems Analysis and Design course, Topic 6. So when we're doing an entity relationship diagram, it's an iterative process just like all the other analysis processes we've been talking about so far this semester, where you start with a simple diagram that gives you an understanding, and then you add to it and you add to it and you add to it, and it grows into a more complete understanding of the data model that we need. So a subject area model is just exactly what it sounds like it is. It's a really high-level model, a really high-level diagram. Basically, a subject area model, or most often, a subject area model just contains the entities and the really important relationships, the really important entities and the really important relationships. It's a way to start understanding the data and understanding the relationships of the data, and then we'll add more detail to it and add more detail to it as we finally develop our real final diagram. So a subject area model is a very high-level, simplified diagram that usually contains entities and relations. So here I have an example. Let's imagine that we have a chain of stores. We've got a group of boutiques that sell stuff. And each boutique is full of items, and we're trying to track our inventory. So a boutique has many items in the store, and an item can be in many stores. So the relationship between store and item is that. And a region, because we have hundreds of these boutiques scattered nationwide, worldwide. Wow, let's go crazy here. So we've divided our stores up into regions. So a region has many stores, but a store belongs to one region. So let's model this relationship, or model these two relationships. Now, the entities that I've mentioned so far are the item entity, because stores have items to sell. The store would be an entity, and the region would be an entity. Are there other entities as we do our analysis and design? Are we going to find other entities? Well, of course we are. But let's just start with these entities. Now, let's model the relationship between region and store. A region has many stores, and a store has one region. Let's read stores belong to one region. Now, it doesn't say 0 or one region. It says one region, and a region has many stores. Can a region exist with 0 stores in it? No. Why would we have a region if we don't have any stores in the region? So I think those relationships are as follows. And let's read the blue arrow. A store belongs to one and only one region. And then a region has one or more stores. So a store belongs to one and only one region, and a region has one or more stores that belong to it. And I've color-coded the arrows so that we can see exactly how we read them. Let's now look at the relationship between items and stores. So an item is stocked by one or more stores, and a store stocks one or more one or more items. So let's read that relationship again. An item stocks, a store stocks one or more items, that's the green arrow, and an item is stocked by one or more stores, that's the blue arrow. So there you can see here an example of a simple subject area model. So here I took that model that I hand drew on the previous slide, and I downloaded a program called Draw.io, and you can either download it or use it online. I like the downloaded version because I can work when I don't have an internet connection. So the program is called draw.io, and you can just go to https://draw.io and download the app or use it online. So there's a shape in the draw.io shapes library called the entity relationship entity shape. And so I grabbed an entity for the store, the item, and the region, and then I drew a line connecting each of them. And then on the line, I went over to where the arrowheads are on the right-hand side of the screen and changed it from being an arrowhead, as the line has by default, to having the appropriate crow's feet. And I made a nice, pretty professional-looking diagram. Let's read this again. A store belongs to one and only one region. A region has one or more stores that belong to it. An item is stocked in one or more stores. A store stocks one or more items. A store with no items makes no sense. An item that we don't sell in these stores makes no sense. So the other thing with draw.io is when it saves the file, it will save it in its own kind of format, and be sure to export it as a ping or some other kind of graphic file so that you can include it into another app. Now, you've been using draw.io for diagrams all semester, so there you go. You're rock and roll. You can do this. Here's a bit of a crazy example. Example 2, people are related to each other. People are related to each other. Yeah, for instance, a person may have a mother or may have a father in our database. So we've got all kinds of people in our database, and we may have your parent in the database, or we may not, and we may have one or two parents for you in the database. So we have this weird thing here of an entity that relates back to itself. And so I have a person has a mother relationship to another person. So let's read this. A person has 1 or 0. Actually, that shape is backwards, isn't it? A person has 0 or 1 mothers in the database, and a person can be 0 or more people's mother. For instance, if me, my sister, and my mother were in the database, my mother could be on 2 of us as mother, but each of us would only have 1 mother. Then there's also the father relationship. So a person can have 0 or 1 fathers, and a person can father 0 or more people. So you get again, that's kind of a crazy example, but I wanted to show that a relationship didn't necessarily have to be between 2 separate entities. A relationship could be between the same entity in itself. Here's a pretty version of that drawn using a professional drawing program. Let's look at a third example. Now, here we go. A student majors in one degree program, and a degree program is made up of a list of courses. A course may be in multiple degrees or may be an elective required in no degrees. Okay, how many entities did you see up in that top problem statement? Well, I think there's the entity of student, the entity of degree program, and the entity of course. Those would be the 3 entities: the course, degree, and the student. Now, a course does relate to a student because students take courses, and a course is taken by students, but it's not listed specifically up here in the problem, so don't model it yet. Maybe as we go into the details of the model, we'll have to add student registrations and grades and all those other things, but let's keep this simple. Let's just model the problem as given. So a student majors in a degree, and a degree has many majors, many students that major in it. And then a degree requires many courses, and a course is in many degrees. because, your English course is in every degree. So let's look at the crow's feet in more detail here and make sure that we've got them exactly. So let's start at student. A student majors in one and only one degree. A degree has 0 or more students as a major. Let's repeat that again. A student majors in one and only one degree, but a degree has 0 or more students majoring in the degree. Let's look at the other relationship. A degree requires one and only one course. No, wait, wrong. A degree requires one or more courses, but a course is required on 0 or more degrees, because a course could be a truly elective course that is not required on any degree, but people still take it at our university because it's an elective. So you can see the relationships, and the relationships were defined by the problem statement. Read the problem statement very closely. Here is a version of the hand-drawn diagram from the previous slide, done using, again, a professional drawing tool so that you can see what it would look like. Now, you may arrange things differently. That's just how I arranged it. The arrangement really doesn't matter as long as it's concise, clear, and readable. This concludes video 6B on the subject area model. This video is copyright 2020 by James Emerno, PhD. All rights are reserved, and I would like to say thank you for watching.